Hi, I'm Sam. Like Matsu said, I am a PhD student in Freiburg with Frankfurter. And this will be like a hands-on session. I'm not as senior as the others. And so you can interrupt me at any moment. Actually, please interrupt me. I think it's more fun than having the conversation in the end only. And I am also planning to start an AutoML company. Let's see how this goes. And I love in context learning. I really love in context learning, and yeah, that's me again. So don't take me serious, I guess, I want to say. And I will have 3 topics actually today, and we will have 1 before the break and 2 after the break. And the one before the break will be a bit less hands-on. We have a hands-on part, but I think it's kind of nice if you do it independently, because you need an OpenAI key for that, and I guess not everyone will have like an OpenAI paid account, but I will like show it to you what it kind of does. We will look at it. For the others, you don't need any key or anything, and you can train really fun neural networks in like minutes, just with like a free Colab, and we will do that. So the first cafe, then we will talk about TabPFN a bit, and then we will talk about PFNs generally. I think PFNs were mentioned before, and I guess most of you don't know what this is. We'll know later. Cool. So let's talk about cafe first. That is very much in line with what you guys talked about before. The idea here is let's try to use LLMs as good as we can to solve our data science tasks or to automate parts of our data science tasks in like a human-centric way, like semi-automate, let's call it, so that we're like faster in our tasks. This is joint work with Noah and Frank. Noah is the first author. I'm here presenting with Noah. The credit goes to Noah. And where does this idea come from? I guess this idea comes from us doing AutoML and realizing, oh, this is actually what the statistics look like. So like the model training and maybe model selection and deploying is like this little bit. And then the pre-processing, visualization, and cleaning is like a major chunk of the work. And with LLMs, I guess for the first time, we might have some good handles on automating that other part, because they kind of can do similar things to us humans, right? So the goal is to do this, to go towards automated data science. We don't claim to do automated data science.
You'd say you wanted to be interrupted.
Yeah.
I would say there's even a component missing. So where is specification and formalization of the task? Because that's usually what takes even the longest, right?
You're right. You're totally right. We took this from this data science report. Maybe you know this. But yeah, I guess they didn't ask people for that, so probably there's maybe they should have.
Oh, that's the most important part of it.
Yeah, it's just that's cool, like machine
learning. I'm not getting it.
But yeah, I agree. The formalization is really hard, like the problem definition is hard. So why is there so little work? Because this is like very human work, I would argue. It's just like you have to understand goals of like a human set problem, typically, like that is like takes place in a human company with like everything's full with humans, and you need real world knowledge to solve such a problem. But LLMs have some real world knowledge, right? We know that, and our method now comes only like takes over a little, tries to move towards like getting a little more of the of the data science pipeline to be a bit more automated. It's only a very minor step, but it's like, I don't know, we tried our best. And the idea is that we don't only automate the model building, now we go one step prior to that, and that will be the data engineering. So we try to automate the data engineering as well. So what we mean by that is most of the time in our case is actually feature engineering. So adding a feature, removing a feature, things like this. Feature engineering is really important. I guess I'm preaching to the choir, but I don't know, this might be a data set. We want to predict what color the dots have, and we now only have one feature, and that's like the day and the month. And it's kind of hard to predict this. if we add a second feature, which is whether a day is a weekend day or a weekday day, the problem becomes kind of trivial, and it's like very clear now that this should be orange as well, because it seems like weekend and weekday is very correlated with the color. And our proposal for an approach is a repetitive pipeline where we ask the LLM, oh, what should we do with our data set? This is kind of what it looks like. Can we add some features? And then it tells us something, we try it out, get a result back, and then based on the result, like whether the cross-validation improved or got worse, we add that feature or we don't add that feature. We perform the task the LLM proposed, or we don't perform the task more generally. And our descriptions, I'm sorry, this is very small, I guess, in the back. So I'll read it out a little bit. So our descriptions look something like this. Here, like this is a dataset description. We took our description actually most of the time from OpenML. And here there's tic-tac-toe. And the description goes something like tic-tac-toe endgame database. This database encodes the complete set of possible board configurations at the end of tic-tac-toe games, where X is assumed to have played first, etc., etc., etc. You might have seen these descriptions on OpenML. Oftentimes they explain the features rather well, and they can actually help you to like build features to solve the task, right? Like no Kaggle user would ever join a competition where they don't read the description. That would be bad, I guess. And then we build a prompt out of this. We don't have to go through that prompt right now. It's like tiny, but what we found out is that actually how we prompt this is very important. So maybe some of you have used like automated data science on GPT, or before it was code interpreter. Like maybe a show of hands, how many of you try to like get classifications for a data set out of automated data science or GPT? Okay, it's like, I guess 10 to 20% or something like this. Cool. Our experience there was very similar, I think, to the grid search thing. Like we asked it like in a very plain way first, and it would always recommend, oh yeah, just do a random forest. I know what random forests are, they're simple, kind of that thing. And it generally also didn't really want to do a lot of pre-processing. So we found like, I don't know, to prompt it a bit more and to tell it, oh, this is what your data looks like. This is how you should behave. You should generally first explain what you're doing and then do it. Stuff like this helped us a lot.
Martin just tried it live on a credit risk data set. And that worked actually very well. And did not recommend grid search. And I'm not sure whether if you would have asked me, whether I would have said something very differently.
Okay.
Look, actually, of course you can always do more, and also our tasks are usually not very specific, right? So we don't talk a lot about, hey, I want this explanation or this inference. It's just like do some prediction and be good about this and so on. And it didn't recommend too much feature engineering, but we also didn't really ask about that. So in terms of what we saw there, that looked very nice, and it took 30 seconds.
That's awesome. And I actually bet that like OpenAI will take over more and more of this stuff. Also what I will present here right now, right? Like if LLMs get better, prompting will get less important. Let's face it, this work will get less important. But I think this approach will still be a thing, but you don't really need to build up on our work because probably the LLM is already really good. Yeah.
Could you go back to the last slide? So you have this loop over there, exactly. So you're using the same conversation, you're like re-prompting again and using like chain of thought or something like that?
Exactly. So what this looks like to GPT is basically one long conversation where first like it gets a long message, which is something like, oh yeah, we have this data set, these are the column names, this is the description for the data set, these are like the types of the columns, these are some examples of we focus on, sorry, I kind of took that as implicit. We focus on tabular data sets only. So this is like, here are a few lines from your data set. And then we ask it whole. So like you have pandas available right now. We give you pandas, do anything with pandas that you want to do on this table. such that our predictions will get better. And then it does like 1 line or 2 lines of pandas code, and then we will do a cross validation on the new training data. If that worked, we will keep that column. If it didn't work, we will tell. Actually, I tell a lot of stuff that comes here. If that works, we will give it a message like this. Oh yeah, it approved it. So we will keep these changes. And I think, I'm sorry. Yeah, actually, this is also keep these changes. Sorry, we don't have an example where we don't keep the changes, but if the cross validation score doesn't improve, it will basically get a message. Oh, what you did is not good. We will not keep this. Please try something else. Does that make sense? And then we just like this thing here is just like that we ask it again and again and again for some fixed amount of iterations. Yes.
So do you like basically use this chat interface where you give like a message response, or
no, we use the
longer?
Yeah. Exactly.
Have you tried the other one as well and found having just one message works better, or?
No, like we always use like the LLM interface where you just do the next.
But even that one has like this chat format where you can say like
okay.
response and. But
I believe we never tried. Like we only tried this for our like initial drafting. Of course, we always use that because that's on the internet. But I think in the end we did not use that. I'm not 100% sure. Okay. Okay. So what is maybe a bit special here is like standard from tuning knowledge, I guess, like let it explain what it does first, then it all of a sudden can count and stuff like this. If you let it explain what it is about to do and what's the like motive behind this, just like as humans. And so we ask it to always first describe the changes it will do to the pandas data frame in some comments, and only then do the changes. And here are the data sets. This is like a very boring slide. I try to keep that out of any presentation I hold. But for this particular paper, and especially given the discussion we had before, it is quite relevant because as you guys said before, there is for sure a risk that ChatGPT or GPT-4, whatever, looked at the OpenML data sets, right? Like it's on the internet, so it's maybe a CSV, but it will have looked at code maybe that was like used to work on these data sets. So there is a good chance that it saw something.
Considering that many of them have also been on UCI for decades, I'm pretty sure that's correct what you're saying. Yeah,
yeah, then even more. And what we try to do against this, I mean, you can't be 100% sure, of course, that the data set doesn't appear anywhere on the internet. You had that discussion before. And the measure we came up with to be kind of sure it's not on the internet was from these ones, but these were like the only ones that were like in our range and we could find. There are Kaggle competitions that are newer than the knowledge cutoff of the GPT model that we used. And you had to click like a consent button to like a consent, like this consent button on Kaggle, I guess, like a consent with the competition rules and whatever. So for these, we're kind of quite sure you shouldn't have seen them, but still, I mean, maybe these are based on other data sets that are actually up there. So yeah, that's a little bit the problem with this paper, I think. It's space Titanic. And yeah, here we see the results, and what we actually did is we compared GPT 3.5 and GPT 4. At the time we wrote the paper, GPT 4 was kind of new, and we first did the experiments with GPT 3.5. And what we can actually see here is that the difference is quite stark. It's like quite interesting, like how many times GPT 4 is better than GPT 3.5, and if they're both like, I think it's typically pretty much the same. So what we can, and generally, if we look at the aggregate scores, it's a similar image. It's a similar picture. Our method kind of depends on GPT-4 actually. So you can see that yeah, we have these huge ranks here, but you can see that the difference between the GPT 3.5 and GPT 4 version of Caffe is quite big for all of these. And here we have actually some more baselines, because the other plot we didn't have baselines. We should of course have baselines. And the baselines we have here are more traditional feature engineering baselines.
Yes. Can you go back one slide just for 1 second? Sorry. Okay. Yeah. So one of the largest differences is actually on tic-tac-toe.
Yeah, so on tic-tac-toe, yeah, exactly. Tic-tac-toe is the cool case, or cool case, I don't know, maybe you find it a strange case also. You can actually, as a human, understand this data set. So as a human, you can also read the description, and then based on the description, just solve that. Like by writing a bit of Python code, you can basically just solve that problem. And yeah, that's why the improvement was so big here. Yeah.
How many loops did you go to the next slide?
Yeah.
For instance, how many times did you leave prompts? The LLM?
I think we set it to a default of 10 reprompts. So it was asked 10 times.
A maximum or every time?
Maximum of 10 times. You could actually say like, I'm done.
Did it hallucinate sometimes?
What is hallucination here, I think, is the question. So it's a very philosophical. No, what I mean is it generates code, and I think we had one instance, and we had multiple seeds, so I think one instance you could think of across like 100 tries or something like this, where the code didn't compile. But for all of the rest of the code, we never got errors. So maybe that was the hallucination. But generally, generated code that worked. Yeah.
If you put a tic-tac-toe example, did it do any preprocessing that's not standard scikit-learn?
No, we generally just took the data set from OpenML and started from
the feature engineering that
the feature engineering that it actually did. I think these are actually real examples from the feature engineering. So yeah, it did very much do strange stuff. So it did very much do what a human would do, be like, oh, is there a row of axes? Is there a row of axes? Then the one, like the axis win.
Do you think it learned that from a website?
There is this risk for sure. I mean, the tic-tac-toe data set is very big. It's on Kaggle as well, and there will be Kaggle.
No, I mean, so like the website that explains how to play tic-tac-toe.
Maybe also that way, yeah. I guess it knows what tic-tac-toe is, right? It's, yeah.
Can you, like with the slide, with the results, briefly explain the relation between the models and the methods and the GPT and like PFN, like how do these relate?
I'm sorry, sorry, I should have explained that before. So the results from this slide here are based on TabPFN and all of them. Because actually TabPFN is kind of nice for this kind of use because it's kind of good performance and very fast. So we can do these iterations really quick. But here we also tried different methods and looked how well we can improve them, right? Because otherwise it could be an artifact that only TabPFN can be improved with this kind of feature engineering. And these are like the other methods that we try out and look whether they improve. One caveat with this table though, because actually GPT-4 prompting was quite expensive in the end for like all of the data sets and all of the seeds, we used the same features that we found with TabPFN on these other data sets. So this feedback loop was only performed for TabPFN, and then we copied like the code over to the other data sets. And what the gist is, at least to me, it was always like with TabPFN, it works really well, and there are others where it doesn't improve so much. Here, like, or with AutoScaler or AutoGluon, the difference is not as stark because I guess they're automatic frameworks. Makes sense. Yeah.
Maybe to follow up, so we basically look at the ranks per row, or are they across the whole table, the ranks, the mean ranks?
I think they're actually across the whole table, which is a bit strange.
Okay, and the other thing that we could basically ask GPT to use TabPFN, or did you ask GPT to do pre-processing and then use TabPFN yourself?
So we did not use Code Interpreter because all these frameworks are not available there, right? They have to install the modules, and I think they have sklearn, but the others they don't really have. And that is why we ask it to generate code, and then on our local machine we execute that code, and then tell it what the result is.
So basically, did you ask it to like include the classifier in the pipeline, or did you just code?
No. It's the code looks really like this. This is actually a real example. The code is just like typically a one-liner on a data frame. That's typically what the code looks like that it generates. Yeah.
Eddie was first.
Oh, sorry, Eddie. Thanks.
So you said only really had access to pandas, right? To feature pre-processing engineering. Do you think it would perhaps do better if it had access to like, sklearn for doing some feature pre-processing? Because there's a lot of examples of like actually using that for feature pre-processing and a lot less specific, like about these pandas one-liners.
Yeah. I guess there is a very good chance of that. So we try to restrict it as much as we can, though, because we're also a little bit scared running like code generated by GPT-4 on like our cluster, and wanted to be sure that this code actually does nothing stupid. So the way we like kind of made sure is that we like when we pre-filtered all of the like pandas operations, we're like, yeah, these are allowed. Other stuff is typically not allowed. But yeah, probably would be better. Yeah, we just didn't allow it. Okay.
I'm not too sure whether I want to be too nitpicky about this, but on the slide before when you had the raw results, was that AOC or accuracy? I mean, I guess I don't even care too much, but
yeah, you're totally right. We don't write it. I think it's ROC, but
AOC or accuracy?
ROC, like our
AOC. Okay. So the thing is, I mean, like what's the baseline? The baseline result is no feature engineering at TAP-PFN.
Yeah.
The thing is, like, if you run like XGBoost on this without feature engineering, you also basically get a nearly perfect accuracy.
That's what we did here actually. So we don't have XGBoost, but what we have is like maybe random forest or AutoGluon, which should be similar, or like AutoGluon should very much be better. And yeah, like we still see improvements, but I guess mostly in the rank actually for AutoGluon. For AutoGluon, they're less dark. That's true. But for a random forest, we can.
Yeah, I mean, the other table, if you would switch out the TAP-PFN to like a standard
XGBoost. Yeah, we're just the developers of TAP-PFN, so that's why we used it.
That's fine.
It's not
that's
too,
fine.
Like, I don't know what the other table would look like with XGBoost, to be honest.
The results are open now.
Yeah. Oh, that's a new trend now. That's nice.
So this is like a question mark to the ballroom. So the tic-tac-toe seems to be like required feature engineering, like the others improve just as slightly. So it would be interesting if there were like more data sets that where feature engineering is pretty crucial to like evaluate it on these where it actually improves the performance quite a lot. One thing that seems about tic-tac-toe is that the machine learning models seem not to be able to count. So maybe this is where it helps, because if it could solve a lot of similar problems, then that would make it even more interesting.
So another case where we saw it make a big improvement, and I think this is also like in the Titanic case. I'm actually this is not part of this table, or no, here it's page of Titanic. Yeah, I'm sorry, the Titanic is not part of this for some reason. But this is the one I remember the most, because there we have like a feature. Actually, we will get into these features later on, but there are like features here. There's a feature that's like a string, which encodes actually multiple features. Like it's a ticket describing first which deck you're on, which cabin you're in that deck, and then I actually don't know what's the third part, but it basically splits that up into multiple categories of made which is of course required. But I don't. You asked to the room, right? So like, if people had experience with favorite data set that has three feature processes, that would be maybe the answer session or something. Yeah.
So my question was also about the results of the report. I think you mentioned
which ones?
Yeah, thank you. There we are. Okay, so here, especially talking about the tic-tac-toe data set, you explained why there was a big step between using ChatGPT and not using. But I am wondering about this big discrepancy between ChatGPT 3.5 and ChatGPT 4, which presents, I think, the largest on that data set.
Yeah.
And the others is
it's not so big,
smaller. So what do you account this for, or what do you think that is?
I actually don't have in mind anymore what are the exact features it generated.
Yeah.
But I guess GPT-4 knows what tic-tac-toe playing is, isn't it? I don't know.
So maybe reading websites about the.
But maybe being a bit more hands-on for questions like this, you can actually consult our repository. There we have, we can consult it together. There we have made public all of the generated code, and there you can look into this and I think V3 is 3.5 and V4 is the first thing is and there, I think these are the different seeds. I guess it's hard to read with everyone in here right now, but the point being, you can these are all empty. Maybe that's why it breaks them. Only this one's cool. Yeah. Okay. So actually, yeah, we're kind of behind schedule. I thought I was so much quicker with this one. So let me go. I think this is the most exciting part actually of the presentation. So let's do this. And that is kind of showing what kind of features we saw GPT-4 coming up with. And we were it was kind of impressive, I would say. So what it did was very much what humans might do. It's here we try to predict an illness, and it will be oh, does the person have fever, and is there another condition being the case? I actually don't know what rhinorrhea is, but another condition. Then we see the binning, which is I don't know, for a lot of tasks it's important. I don't know, you want to maybe classify whether someone can watch a movie or so. It's not important what exact age they have, but are they childs or teens or adults? So it did grouping of ages, and did that for the spaceship, for the take a spaceship case. So where we want to predict who survives an accident of the spaceship. And the string transformation we talked about before, and here we have removing features, kind of boring to be honest, but yeah, can also remove features. And here we see the case where it actually did produce code that produced an error. This is, I wouldn't call this a hallucination in this case, I would say, but it's just bad code because it didn't handle a corner case. And we can actually tell it, oh, this code errored with this error, and it will generate new code. But I guess that's not very surprising to people that use GPT-4 before.
Rhinorrhea is the German Schnupfen.
It's Schnupfen, all right.
A runny nose.
All right, yeah, so. Good to know. And for the safety, so that was actually for our reviewers, for maybe people that want to write a paper as well about LLMs for AutoML. For our reviewers, safety and ethical concerns were very important because we run code that the LLM generates. And our solution, I think there is no waterproof solution, to be honest, or at least we didn't find it, or we couldn't find it on the internet or anywhere. Our solution was to whitelist what the model can do and basically come up with a list of commands the network can do. You can also find that in our code base. And we try to have it interpretable as well, where the way it comes up with the features is actually kind of interpretable because it will explain first what its reasoning is behind generating that new feature. But of course it can lie, right? It could lie and actually have that feature for another reason. I guess that's not so clear. and it will very likely replicate biases. We also tried it out, like here we have it, we had an adversarial example where we could very well make it create features that replicate biases that we have in society. I think here it's around whether a doctor is male or female and the nurse is male or female, and it had that tendency to make the nurse female and the doctor male. All right. The conclusions is, I think this is a very initial work towards using LLMs for AutoML. We only tackle feature engineering in this work, but we still can show that like this interactive approach or this iterative approach seems to work, and in a lot of cases our language models are actually there. They can help us already. Like we're already there where they can help us. And I can show you, maybe I just scroll through the notebook right now because we're so late. But if you have an OpenAI key, you can also run this notebook. It's linked in our GitHub repo. And so what we do up here, you know this, the imports.
You zoom in slightly.
Yeah, sure. Is that enough?
Yeah.
Cool. And you can now call this in kind of similar, at least, to a standard sklearn interface. And what this will do now is it will run the whole Caffe program in the background. So here we see a part of the prompt. So like the important part of the prompt we see here. The prompt is actually a bit longer. Maybe, yeah, no, we don't have to look at the prompt right now, but the prompt is a bit longer. And this is like the changing part of the prompt. And sorry for the warnings. Actually, we wrote something, so we have a lot of warnings. And now we see like iteration 1, and this is what GPT-4 actually generated. And this very much works right now. I generated this on the turn right here. And we see, I actually didn't read it before. Okay, yeah, I guess, yeah, sorry. We do tic-tac-toe and it generates this diagonal feature, if I get it right. Sorry? Rerun it, but then I don't know what this should help. I have to run it from the top. But you want to see it running, I guess. Okay, all right. Can I run everything? Actually, restarting as well. That's okay. Now it installs again. It should have everything installed already, I thought, at least, because I ran it before, and it seems like it's doing it again. But okay, we're done. Cool. Okay, so here we do imports, you know this. I will try to moderate this a bit to make it a little bit interesting. You get my OpenAI key, which I hide from you guys. Now we download the datasets, and it seems like I'm actually on a completely new instance. That's why my OpenML cache is even empty. We download from OpenML right now, so this will take some time. And what we do here now is we set like our data set that we want to test. So if you run this yourself, you can like select the data sets out of the data sets that we had in our benchmark, whichever you want. We select number 5 here. I think this should be tic-tac-toe. No. 5, yes, this is tic-tac-toe. And there we do like a first iteration down here, which is just the TabDFN. So like some classifier, let's call it like whatever is similar to XGBoost or something in the usage. And then we perform the same classification again, but with Caffe, and this iterative procedure goes on. And here we see the prompt, and now we will get a lot of warnings. Sorry for that.
Ignore the warnings.
I actually try, yeah. Let's see if it seems like actually that it ignores them right now, but I ignored them before. Like I added that code on the train app. They're back anyways. I thought I ignored them too. And yeah, now we have the first feature, the diagonal. Same feature actually as before. GPT-4 is not reproducible. Yeah. So yeah, I think now it's exactly 30.
Did you increase the area on the curve?
Okay, you look way more closely to this than I am. Okay, block did not improve. And the changes were kept because accuracy didn't improve. And I guess we need to run it for a bit longer to get to better scores. This is only 2 iterations, and you can specify the number of iterations here. So it goes from 10, but we're like at the end of the time.
Maybe run it in the break, you can watch it and then get a coffee. Or like the other way around, people get a coffee and then watch it.
All right, we'll do that. Yeah, then let's have a break. Yeah. Or should we do a discussion before? Like, yeah, the link to the notebook. So I think the easiest way to find it is you go to our repo. So our repo is under AutoML/Cafe with 2A. This here. I hope you can find this. And then in here, there is a link. There's a link to, there's a link to the demo here. That's the notebook. So AutoML/CAAFE, and then click the demo link there. If you have a ChatGPT key, you can use it. If not, you're out of luck. I'm sorry.
Can you hook it up to 3.5?
You can, yeah. You actually, when we look at the demo, you can choose this here. That's the string that's passed to the OpenAI API.
Or you just have to, I guess, like set up OpenAI API account.
You just need like an account. Yeah, you need an account there.
But is it hard to get an API key?
No, you create an account, put your credit card in, and you have an API. But it costs.
Usually, even with 3.5, it's like 3 is ChatGPT, but with the API, it's
no 3.5. Okay, let's continue with the hands-on stuff, or let's like look at the generations first. I'm really sorry about all of these warnings. So before the break, I was asked, oh, can't we like run it for 10 rounds instead of only 3 or 2 rounds? I think it was on the tic-tac-toe data set, and see where it gets. And we can see it gets to actually this is bullshit. It gets to something like here we see rock 0.8. It started at 0.7, I think. It did improve, but we can actually see that it also created. I saw creations that were bad also. That was cool. So here it tried to access a row that doesn't, like a column that didn't exist in the pandas. And it did that actually many times for different rows to try it out. And it also generated code before where it actually like decreased performance of the TabDFN, and this was then left out. Okay, but now I would close the cafe, or is there like one urgent last question regarding cafe?